Welcome back. Just a video on, we're starting on reciprocal trig functions. Okay, reciprocal trig functions. And the three reciprocal trig functions are sec x, cosec x, and cot x. And what these are, sec x is 1 over cos x, cosec x is 1 over sin x, and cot x is 1 over tan x. So they're our three ratios. Oh, those are three ratios that we need to know. And so there we go. What we'll do first is sketch them and have a look, I think, what they look like. And then we'll get on to sketching a couple of these and some transformations of those. Okay, so let's do that. Let's sketch. Firstly, we'll sketch sec x. So let's have a look at sec x. I'll just get rid of this, and yes, I just said it already. Sec x is easily to you easily say sec y equals sec x, okay, which is 1 over cos x. Now, firstly, let's just think about what cos x looks like. And to remind yourself about what these things look like, just always sketch the graph of cos x. So down here we'll do, we'll do pi there, and 2 pi there, and do negative pi, negative 2 pi, and we'll have 1 there, and negative 1 there. Okay, so what does cos x look like? And then you can figure out what 1 over that looks like. So cos x, remember, starts at 1 up here. It drops down pi on 2, not very good and clear, but it goes up to there and to 2 pi and then keeps going, etc, etc. Now this side comes down. Sorry, it's a bit hard to draw on the computer. Oops, that is really bad, but you get the idea of something like that. Okay, and so think about if you divide each of these y values, 1 divided by these values, think what you get. What you get every time it crosses the x-axis, you get asymptotes on these lines here. Okay, every time it crosses over the x-axis, you get asymptotes, and this is what happened. And apart from that, what will happen? Well, what happens is, and I explained this more in class, but it comes down to here and then goes back up like that. Down here, it comes up the asymptote, turns around and goes back down at the point 1 there, because 1 divided by 1 is just 1. So it looks like that. Sorry, bad drawing, but again, on the computer it's just really hard. So please forgive me. So it looks something like that. So in red is your graph of y equals sec x, and it's just really important to note what the asymptotes are. Okay, so it has asymptotes at, where does it have it? Well, it has it at pi on 2, 3 pi on 2, etc, etc. Or a better way to write that would be at pi on 2 plus, how far apart are they? Well, they're every pi, so plus k pi. And we have asymptotes that far apart. And pretty much, if you know your asymptotes of these reciprocal trig functions, that's all you really need to know to be able to sketch them. So that's the most important thing. In class, I think I talked about minimums and maximums, which is also helpful, but this is the main deal. Okay, so now let's have a look at y equals cosec x. I'm just going to close this and then open it up again, just so I've got a nice new one. There we go. Okay, so let's have a look at cosec x. Okay, y equals cosec x. So this is, remember, that is 1 over sin x. So let's just draw our sin x here. So I've got pi, 2 pi, and we'll have negative pi, negative 2 pi. And let's just draw our sin x, 1 to negative 1. So sin x goes through the middle, up to pi on 2, down to there, up to there. I'm getting better, that's pretty good. And down to here, up to here, something like that. Okay, that's what our sin x looks like. And now let's do the reciprocal of that. So remember, every time it crosses the x-axis, we're going to get an asymptote. So asymptotes, whenever it crosses the x-axis, so 1 through the axes there, there. You get the picture. I don't need to keep going, do I? But you have all these asymptotes there, and again, just like cos x, it comes down to the asymptotes, meets it at 1, and goes back up in that direction, up the asymptote, down. So you get up, down, up, down, up, down arches, as we discussed in class. Okay, something like that. So we've got our y equals cosec. Whoops, there we go. Y equals cosec x graph there. Again, all you really need to know is the asymptotes. Everything else you can figure out yourself. Asymptotes occur at, well, let's have a look at it. We've got 0, pi, 2 pi, etc. Or a better way to write it is just k pi, where k is an integer. I didn't write k as an integer before, but k pi. It's just all your pi. 0 pi, 1 pi, 2 pi, 3 pi, etc. That's our asymptotes. Fantastic. Let's just quickly look at the graph of cot x. And then we'll be up and running, and then we can sort of discuss sketching these guys. So y equals cot x, which remember is 1 over tan x, and let's think about the graph of tan x. So I'll spread this graph out a bit wider. We'll have pi on 2 here, and pi. We'll have negative pi on 2, and negative pi. Now, so you need to get good at this. The graph of tan x has its own asymptotes already at pi on 2, negative pi on 2, etc., etc., like that. And the graph of tan x comes up, goes across at 45 degrees and goes up like that, and it keeps repeating, etc., etc., like that. So that's the graph of y equals tan x. And that has asymptotes at negative, well, pi on 2 plus k pi. Yeah, that's right. And so let's just have a look at this. Now what will happen if you divide everything? Well, wherever this crosses the x-axis, you're going to get, so for cot x, sorry, you're going to have asymptotes wherever it crosses the x-axis. Okay, so this is for cot x in red. We have that, and we'll just think about what happens as this line gets closer and closer to 0. This one gets closer and closer to infinity, and so it comes across like this. As tan x gets closer and closer to infinity, this line gets closer and closer to 0, so it comes across like that. This is a terrible drawing, I apologize. And then from here it goes back and that way, like that, and goes to the asymptote. So it's actually like a bit of back to front. And so I'll just do it again here so you can see it a bit clearer. Try and draw it a bit better. And so you've got these back to front lines. And so so tan x goes sort of left to right. If you're drawing them, they sort of squiggle from left to right, going from up to down. And cot x goes from right to left. So you can just think of it as being opposite, if that helps. Fantastic. What are our asymptotes? Asymptotes, let's have a look at it, is 0, pi, 2 pi, etc. Or a better way to write that is just k pi, where k is an integer. And so that's pretty much, if you at least know the asymptotes of these three functions, then it makes sketching transformations of these things a bit easier, which is what we'll do in the next video. So there you go, there's your three functions of reciprocal trig values: cot x, cosec x, and sec x.